Okay. All right. Well, thank you everyone for joining. This talk is going to be about requirements traceability using code coverage. And a little bit about me. My name is Rachel Sibley, and I'm a quality engineer working at Red Hat. Been with Red Hat for about 7 years now. Currently, I'm working as the QE technical lead for the new Automotive initiative at Red Hat. Previous to Automotive, I worked in kernel QE team with a focus on kernel CI, where I was a test lead for responsible for coordinating test coverage for the kernel. So a little bit about what I'd like to talk about. This is a rough outline of the agenda. First, I'll provide an overview of what Rivos is, Red Hat's in-vehicle operating system. You may have attended the talk on Monday given by Jeffro and Gab, where they gave an overview, and then there will be another more focused talk after this. Talk about the importance of running code coverage in safety critical applications. Take a look at what we currently have for Red Hat using Red Hat CI testing system, CKI, and improvements we'd like to see going forward with next steps. So what is Rivos, which is short for Red Hat's in-vehicle operating system, easier to say. Red Hat has joined the automotive space and would like to deliver the first certified, continuously certified Linux operating system for road vehicles. It will be based on RHEL or subset of RHEL, and we're going to want to reuse and leverage RHEL's existing testing and development practices for automotive. So we're currently working with the certification body, EXTA, to navigate the certification process. Requirements are going to be closely tied to both the customer engagements and also the certification process while we identify potential hazards and also review potential gaps in our current practices in test coverage. So the ISO 26262 specification, which is standard for functional safety in road vehicles, includes a statement on the importance of code coverage and traceability to software requirements. Code coverage becomes increasingly important according to the ASIL level. The ASIL level refers to the Automotive Safety Integrity level, which can be used to classify risks. By using code coverage, it enables us to provide the evidence and traceability that our testing is either sufficient or we have gaps in our testing which need to be corrected. So CKI is Red Hat CI testing system. It stands for Continuous Kernel Integration. Originally it was called Kernel CI, but of course that name was already taken. Actually, CKI now works together with kernel CI and other upstream testing systems to consolidate test results into a common dashboard called KCIDB, kernel CI database. CKI is currently responsible for testing and gating RHEL kernel development patches using GitLab merge requests and also on the official builds. There's also a lot of interaction with upstream kernel subsystems where they're testing certain upstream kernel trees, providing feedback to the maintainers. Whichever upstream subsystem maintainer will allow us to test their kernels. All the results are pushed into a visual dashboard referred to as the data warehouse. And this is to be consumed by both internally for Red Hat and also by the upstream communities who have onboarded to CKI services. Until recently, data warehouse was actually only internal to Red Hat, but recently it was pushed to the public so that we can now have this availability to the maintainers who are using CKI services. So CKI has a lot of nice features, but some worth highlighting, especially for the focus of this talk, is both the targeted testing, where we want to run meaningful tests based on change sources for the patch series, and also code coverage analysis, where we're generating code coverage reports in the pipeline using gcov and lcov to generate the HTML reports. For code coverage analysis, this is still very fresh, at least for building the gcov kernel and running the reports in the pipeline. There's work ongoing to push results to data warehouse and run it at a regular cadence in the pipeline. So right now it's possible for a kernel developer to update a config file for a given merge request since kernel development has moved to GitLab. And you can trigger code coverage testing as needed. So it's really there as an optional way to see test coverage for proposed patches. So there's also work to re-enable this for baseline kernels, as this was previously running the old method where we were actually fetching pre-built gcov kernels. So this will allow us to allow test maintainers to easily trigger code coverage by calling a bot to generate a report as they onboard new test coverage or update existing test coverage to test new features. So as I mentioned, it was previously enabled as needed by fetching a pre-built gcov kernel, and it was fetching tasks internally from QE, but there's a lot of work recently to update the tests so that they're open source, the wrapper scripts, so they're open source so that we can now use this eventually for upstream kernels as well. And the tasks, the wrapper scripts are actually in the kernel test repo, which I can post a link. And I see I didn't post a link here, but I can post it in the chat later. So here's an example of the data warehouse. Anyone can view it in the public as an anonymous user. You're limited to upstream kernel results, of course. Red Hat users would use the single sign-on to log in, and then they can see the internal kernel results. I added a link to the bottom of the slide if you'd like to check it out. There's not only test results for each kernel tree, but you can take a look at the existing testing trends and related issues found by the triage bot. In the dashboard, you can also view recent kernel testing trends to determine if a test is flaky or not. And there's also a view of current issues that were tagged by the triage bot. The triage bot uses a predefined regex pattern where it can automatically scan predetermined log files to tag a known issue. So this is another view of the data warehouse where we're actually drilling down on an actual build that they're testing. Now you can see linked at the bottom where I highlighted in red where it's actually showing the code coverage report log file. You can click on that, which links to an S3 bucket, which shows the HTML report. The feature is not yet merged, so I actually had to take this from a pending merge request from a screenshot, but shortly the feature should be added to the pipeline soon. And here's another example of what the report may look like, depending on how granular you want to run it. You can hone in on specific kernel directories. So for this example, we're running XFS tests, narrowing down on just the XFS directory in the kernel source, using the kdir parameter that's used by the wrapper task. It automatically pulls in coverage for related libraries as well. I believe you can set the limits of what the coverage should be in the legend. And this one, it's actually set for green is 90% or higher, which is quite high. So I think that we might want to adjust that depending on what we're doing, based on what the needs are for the team and what we're actually testing. So obviously, if you're running this for the entire kernel source and running XFS, the coverage is going to be low. But in this example, it's not too bad. So another method worth mentioning to measure code coverage and traceability to testing requirements is the use of CKI's feature for running targeted tests. So to provide an overview, CK has a tool called KPET, Kernel Patch Evaluated Testing, and it will evaluate each patch under test and automatically run matching tests which relate to the changes introduced in the patch. So it's using a regex pattern which relate to the test in the KPET database. So these patterns need to be added ahead of time when you're onboarding a test, and it will trigger automatically as patches are tested in CI based on changed files and directory names. It can also be used to categorize tests. So you can run a subset of tests which relate to a kernel subsystem. So for example, you can run all the networking tests against the NetNext tree. Or you can categorize them by a given feature if you like as well. So KPET is the framework in CLI where you actually generate the XML, which is the input for Beaker and Restraint, which is what we use internally for Red Hat. And KPET DB is the database which defines the conditions for each test case, including how and when to trigger. And Beaker, just to give some background, is the actual infrastructure of framework that we use, which houses all of our inventory and allows us to target specific hardware, and the test harness is run in Beaker, where we use restraint harness. So both KPET and KPET DB are tightly coupled to restraint in Beaker, so it's not that portable unless you're using restraint. There's also an option to target specific hardware and related drivers, which would depend on certain test coverage. So right now we are running a limited number of targeted tests on kernel patches, but expected spring of next year, they're working on actually a feature where they would actually block on kernel patches that are missing targeted test coverage. Right now, it's just informational, where it specifically will point out you don't have targeted test coverage, where the idea is for Devel and QE to work together to go and review the current test coverage and make sure that they have targeted test coverage running. But in the future, we'll actually be blocking on those changes until the tests are onboarded and running in GitLab. So if you want to check out more detail, you can take a look at the source code, both KPET and KPET DB. Oh, how do we test requirements today in Red Hat? In Red Hat, we have a process called dev.test. It was essentially a work group that was formed a few years ago because the idea is we want only pre-verified content to land in a compose. So the idea is to shift left our testing, development, documentation practices earlier in the release cycle. So this diagram, it's showing the existing workflows for a given Bugzilla or RFE that would land in Bugzilla, and the workflows and best practices, including the new kernel workflows. It's closely tied to the Bugzilla states, so since this is where a feature first lands in RHEL, it's intended to show high level how we commit and test a feature. So I don't want to go through the entire diagram here, but what we're proposing here is to enable code coverage as a standard practice earlier in the development cycle. So while QE and Dev are working towards onboarding new test coverage, we'd like it to be a standard practice to run both code coverage analysis in addition to running targeted test coverage as new test cases are added or improved to test a given kernel feature. Then later on, once test is onboarded in CI and running on test builds, it will run by default in CI on maybe a draft merge request, and it will provide that visibility so that if the test case needs to be tweaked to add more coverage, we have the opportunity to do that at that point. And that way we make sure that we're sufficiently testing a requirement. So, proposed code coverage analysis improvements. We're having discussions now thinking about what would be useful for running code coverage. And we have some user stories circulating now, how we can use this across not only Rivos, which is a subset of RHEL, but for the entire organization. So we have some high-level improvements we'd like to work towards, including running both component level test coverage and then more granulated reports by kernel subsystem, and run those at a regular cadence. In addition to running the reports by default for kernel development merge requests in GitLab, we'd like to have those run at the requirements level. So being able to automatically identify a patch series that relates to an RFE or a feature, and then running that by default. Instead of having to inspect and drill down and look at each result, we want to be able to see a trending progress or a positive improvement that we are actually improving test coverage. So pushing the results to something like Grafana would be useful. And yeah, as I mentioned, having the reports run at a regular cadence and stored somewhere that are accessible for sharing within the organization. So it will help encourage other subsystem teams to onboard more tests or improve existing coverage. So what are the next steps? Document and get consensus on the agreed upon code coverage user stories across the organization. Since this is impacting not only Rivos, but also RHEL, we need to circulate this across the organization and agree on how we want to do this as best practice for Red Hat. Work on defining the best practices of running code coverage and what cadence we'd like to run them on and document it, embed it in the existing test and CI workflows and also the dev.doc test practices. And as a priority, we'd like to work on prioritizing this for the in-vehicle OS components. And that's it. So finished a bit early, so we have time for questions and discussion.
Yeah, there are a few questions in the chat. Rachel, if you want to take a look. The first one is, what are the challenges, if any, in adapting RHEL, CKI, and quality measures to RH in vehicle?
Yeah, so there's some of the challenges are, we're going through a lot of these exercises with our certification body, and we're noticing there are clear gaps in the way we do things from a testing perspective. So there's going to be a lot of influence. We want to be able to backport the changes that we make in Rivos also to the RHEL organization. So being able to influence the rest of the organization to be able to have these opportunities to shift left and remove the gaps that we're identifying is definitely one of the bigger challenges, since you want to, in a way it's going to be extremely useful for RHEL, but we also want to make sure we're doing it in a way where we're not affecting RHEL and affecting the RHEL schedules, but from a quality perspective, it would be a good benefit for RHEL. Okay, so let's see, does GCOV handle MCDC? If not, what do you use for assessing MCDC coverage? There might be a way where you can configure the LCOV tooling to focus in on MCDC coverage. I'm not sure. I think there's different ways where flags you can add to the gen HTML function, but I would have to look, but that would definitely be something useful. And yeah, I see Gab said it's not required because of ASIL B. Okay. So let's see. Paulo, Red Hat plans certify using part 6. I see Gab's answering my question, so I'm just going through. Yes, we'll give an overview of the Red Hat approach in the next talk. Would you be interested in sharing how many patches can actually be checked with the current test suites? I.e., there is at least one test run on that actually executes a changed line of the patch. I think knowing that number even approximately would be interesting for the community. Are you asking how many patches can be tested with the test suites that we have onboarded for Red Hat, or like what is the actual gap as far as what is a percentage of targeted tests that we are running currently for incoming patches? Lucas, are you there? Maybe you can elaborate a little bit.
Yeah, so the challenge is that I think there's an urban legend, many know that, right? You can get patches into the kernel without it ever being tested by any test system out there. And the question is, of course, are we talking about 5%? Are we talking about 50%? Or are we talking about 95% of the patches are actually never tested? Just to have an indicator where we stand with the number of patches that go into a release that have never been exposed to a test that actually tested that change. That would be very interesting, I think, for community in general, but as well for all stakeholders that use Linux and think, oh, the next version, it was tested, right? Because if you tell them, well, 90% of the changes were never actually exposed to a test, then they might think about you not using it, or in the better way, getting more engaged in putting test resources, writing tests, and providing better quality control.
Well, I can see internally for Red Hat.
You're close to have that measurement, right?
Yes, yeah, it would. I can say internally for Red Hat, every patch is tested, but is there meaningful tests that are actually running on that patch series? So, or kernel, we moved to GitLab merge requests for kernel development, and every merge request is tested. There's a default set of tests that run, including LTP.
Yeah, the challenge is, of course, right? If you modify something in some file, it really doesn't matter if you'd say, well, I've tested test, because you never know if the change was really exposed to any execution.
Yeah, right. That's the point of the targeted testing. Yeah. We want to make sure that we're actually running meaningful tests on every patch. And right now, just a select number of patches are actually running targeted tests. But what CKI wants to do in the future is actually block on patches that aren't running targeted tests. So there's going to be more of a more of a formal process that will actually block these changes from being merged unless we are seeing meaningful tests run. So, but it's going to take a little bit of effort to make sure that we have the tests onboarded ahead of time or in the process of developing or proposing these patches in GitLab. So as the patches are being proposed in GitLab, developers should be working with QE and making sure that we have these meaningful tests running in addition to using the code coverage analysis. But I don't have exact numbers about what we currently have for what is the targeted percent level across patches internally for Red Hat. But it's probably less than 50%, but we want to get it higher than that. So that's one of the one of the big things that they want to work towards, I know, for the next few months.
Yes,
Thank
of
you,
course,
Rich.
the
There
community
is,
is even more interesting.
sorry, Lucas, there is
Sure.
another question from in the chat as well.
Okay, sure. Can you provide some details about the certification from Exida? Is it similar to CodeThink? We saw yesterday that focuses on the process and tool qualification, or with the certification of the in-vehicle OS. Has the certification been completed, or are you working towards getting the certification? We have not completed the certification. We just started the process a few months ago. But I think this is probably going to be discussed a bit more in the next talk, and Gab probably can provide more details about the certification process, what we're doing with Red Hat. But for what we've done so far, the two main exercises are the HARA, the Hazard Analysis and Risk Assessment, where we are identifying potential, brainstorming potential hazards that could happen in a car. And then the other big exercise was the gap analysis, where we are going through and working with Exida about all the various processes and things that we would like to follow, and identifying the gaps across the organization, what rivals would need to follow. So a lot of this work is currently being scoped out and analyzed, and will be moved into tickets, Jira tickets, this is how we work on tasks in Red Hat. So it'll be a bit of a process, but yeah, still in the beginning phases. Let's see, any assumptions you've made for software safety requirements when planning testing? So yeah, I think that's something that we've been discussing in the HARA, the Hazard Analysis and Risk Assessment, about looking at our current testing that we have for RHEL and what are potential hazards that might happen, if there's any gaps in our testing, or maybe we need to add more penetration testing for specific use cases related to safety. So these types of things are still ongoing, but mainly discussed in the HARA. Can you speak to incremental testing on patches? Shua, can you maybe elaborate a little bit about what you mean there?
Yes, you might have a battery of tests for a particular subsystem. When you test a patch, do you take into account that you're actually doing the incremental testing on that? And can your test reports provide incremental test results? Meaning, are you focusing in on the changes made by that particular patch to the code base?
Yeah, I mean, I think that's sort of the point of the targeted testing. And then especially if there's a draft merge request and a developer is working on pushing changes, and we have specific tests run, including the targeted tests, as they add more changes, then we want to see if other targeted tests are being brought in as they're working towards that. So yeah, sometimes a patch series will get knocked, and then there'll be another revision of that patch where we'll pull in more test coverage based on which test it's automatically pulling in from the KPAT database. The next one was about, can you share your slides? And yes, I will post that in the chat or upload them. Sorry about that. And I think that's it. We run out of time. So thank you so much, everybody.